Hey there, welcome back to Water Finance Management Conversations. I'm Andrew Farr, Managing Editor of Water Finance Management Journal. Today we're going to have a quick but detailed discussion on prioritizing assets using risk-based planning. So we're going to talk a little bit about transmission lines and distribution mains, how the approach for monitoring and managing these pipelines is a little bit different. We're going to talk about assessing risk and how tracking all of this data can be used for future investment and where to prioritize spending. So in order to help me discuss all of this, I have a wonderful guest joining me, Greta Vladeanu, Senior Program Engineer for Data Insights with Xylem. Greta, I'm really looking forward to talking with you a little bit today. I'm going to start you off with this question. What advice would you have for utilities, first off, in developing a pipeline management program?
Thanks for having me, Andrew. So the challenge of managing aging infrastructure with those limited financial resources has forced many of our customers to seek out more innovative solutions to prioritize their most critical assets in order to optimize their spending budgets and maximize their return on investment, reduce the risk, avoid pipeline failures, and really ultimately extending the remaining useful life of their assets. So having an effective pipeline management program entails planning for the full life cycle of the assets, starting with the initial risk assessment and intervention planning, and then moving into condition assessment, feasibility evaluation, and preparation for that condition assessment project, then actually performing the condition assessment of the pipeline, and then incorporating various structural engineering and statistical predictive analysis to develop those short and long-term asset management plans. So this process is a proactive asset management process, and it's holistic and it's cyclical. It's not a one and done process that begins and ends after the asset has been assessed. So I think this is the most important takeaway and advice that utilities need to be aware of and embrace as they navigate through their asset management journey.
And Greta, how is managing these types of programs, how is it different for distribution systems versus transmission lines?
So when we talk about a distribution system, the goal there is to decrease the failure rate or the pipe break rate. So the strategy is to proactively identify and prioritize the mains that have the highest predicted probability of failure. And then in most cases and most often, utilities will start planning a capital replacement program. So this way, the highest probability of failure pipes are removed from the system over time, and that leads to those decreasing failure rates over time. So compared to this, when we talk about transmission systems, the goal there is to avoid those high consequence failures, even though usually these types of events are rare among transmission mains. But in this case, now the primary driver for prioritization and inspection planning becomes that consequence of failure component, because there is usually not sufficient historical failure data for those larger transmission mains. So that predicted probability of failure becomes less precise and less reliable. And managing transmission mains is best accomplished through inspections to preemptively locate those defects for timely and proactive repairs, as opposed to replacing them as we do it with distribution mains usually. And also, as part of planning and managing transmission systems, once those planned pipeline assessments are performed, then opportunistic inspection and repairs of valves and other appurtenances can also be achieved.
Okay, let's talk a little bit more about risk. How can utilities quantify risk and use that information for future planning?
That's a very good question, and we'll spend a little bit of time discussing that because I feel it's very important to emphasize on that. So the widely and most often used risk assessment framework in the industry today is a qualitative or factor-based approach. And that usually entails assigning discrete scores of most often 1 to 5, and those are assigned by decision makers to a series of defined factors to then evaluate the asset's risk through probability and consequence of failure. There are several challenges and limitations of using this type of risk assessment. I'll just mention some of the main ones. So first of all, these types of models rely on that factor-based reasoning and human input, and that can lead to biased results. These models typically require complete data of the system, and most often the attributes of the pipe actually have a significant influence in driving the risk profile of the asset, and that is really not an adequate measure of risk. To give an example, pipe diameter is often used as a surrogate for assessing the potential impact of flood damages. But this does not really capture the severity of the actual impact. And I left it as last, but probably one of the most important limitations of using factor-based models is that uncertainty cannot be accounted for because of that discrete nature of the assigned scores. So we assign a risk score of 1 or 2 or 3, and we say, okay, that's for sure. Fundamentally, uncertainty is the reason for risk analysis. Otherwise, we would know the exact time and location of a water main failure. So assigning these scores of severities, it cannot be objectively done for consequences that are uncertain. And to give an example for that, if we think about a transmission main that breaks and floods a highway during rush hour, so that consequence of failure has a different, and it has a higher severity compared to if the same transmission main fails during the night when traffic is lower. So when I mentioned earlier that uncertainty of the consequence, this is the uncertainty that cannot be taken into account using these factor-based models. And to overcome these limitations, when we talk about a quantitative risk framework, that is recommended because it integrates probability of failure evaluation through more advanced statistical analysis and machine learning models. And it also incorporates a monetized consequence of failure analysis using peer-reviewed and industry-backed cost information. So now this approach eliminates those limitations that I mentioned earlier. And now the risk model, it relies solely on system data, and it removes that human judgment from the risk assessment. And it can also use incomplete data and make inferences because it is built on mathematical equations and statistical analysis, and it derives those objective risk results. So, for example, going back to that factor-based model and how the pipe diameter is used usually as a surrogate for that flood damage potential, in the quantitative risk analysis, we perform flood simulations to evaluate the potential flood damages. And for that, we use specific software and a series of data sets such as elevation profiles of the system, pipe flow information, proximity of the pipe to other infrastructure and buildings. So that helps us to see that potential flood impact in a more objective manner. And after all the analysis is completed, the resulting risk results now reflect how likely the expected monetary loss will be. And again, going back to that most important limitation of the qualitative model that is now eliminated here is that the uncertainty of the outcomes is now accounted for through the modeling process using probability distributions rather than assigning just one single value to a parameter. So going back to the example of that highway impact during a pipe failure, the impact now is not a single monetary value, but it's rather a range of potential impacts that now includes that uncertainty of the consequence of failure. And so to tie it back up and to wrap it up, having this quantitative risk assessment becomes more practical for utilities because it can now focus on areas in the system that are critical, and it results in that quantified risk for prioritization purposes. For example, if we think about an inspection program development, depending on the risk profile of the asset, different reliability condition assessment technologies can be assigned to that asset, ranging from high resolution inline inspection tools to screening level tools like leak detection or transient pressure monitoring.
Greta, this is really great information, and we really appreciate you spending some time with us today. I want to finish up with this last question and ask you if you could talk about some utilities that are using this approach now. And just as a next second part to that, can you give us some examples and maybe some lessons learned that you can take away from those?
Definitely. So we have worked with a wide range of utilities from small communities to large metropolitan water systems, really all across the globe. And we help them develop these targeted asset management plans at both system level and asset level. And to give you a couple of examples, the city of Aurora in Colorado, they have implemented this quantitative risk assessment to justify a nearly six-fold increase in their 3-year capital improvement budget for pipe repairs and rehabilitation. And another example is we are working with the city of Baltimore in Maryland to enhance their valve management strategies by incorporating valve criticality analysis to prioritize the rehabilitation of their most critical inoperable valves. So this analysis helps the city now shift their focus towards the most critical valves in their system that are currently not operable, so allowing for this more optimized resource allocation and address those immediate needs for improving system operations, while also aligning with the city's long-term goals for system sustainability and overall reliability. And to answer the second part of the question with the lessons learned is that, as I mentioned earlier, we work closely with so many utilities on their asset management journeys. And the biggest lesson learned is that we have to meet them where they are. So this means that we always and constantly tailor and update our approach to ensure that we are meeting the goals and objectives of our customers, knowing that each of their systems is unique, they have different levels of data availability, and they have different needs for current and future planning and investment. So regardless of all these aspects, our main goal is to drive actionable and data-driven recommendations to ensure that their budget spending is optimized to address their most critical areas in the system for obtaining and achieving that long-term reliability and sustainability.
Greta, thanks again for joining us today on Water Finance Management Conversations. It's been a pleasure.
Thank you so much. It was a pleasure being here.
And we will see you all on the next edition. See you next time.
Subscribe to Water Finance and Management's YouTube page and visit waterfm.com for the latest water industry news and insight.